Good morning, everyone. Glad to be here. I'm Mehdi Abdelwahab. I'm a consulting ASC for Apstra, the product that has been acquired by Juniper a few months ago. So we're gonna stay in the automation domain and more towards data center. We are a data center network automation solution, and I'm going to elaborate on that. But at a high level, when we look at data center network operations and the usual challenges that we observe in this area, so we generally have those two personas, the architects and the operators. So sometimes in some organizations they can be mixed, and in other organizations they are separate, and they do have different challenges that they face daily. So not going through all of them, but typically the architects will be those of you who are in the network architectures. You probably care more about selecting technologies that gives you freedom to enable and activate services in a seamless way. So you look for activation delays and shortening those delays and enabling service activation as quickly as possible from an agile standpoint. Those of you who are in the architect teams as well, you care about vendor flexibility, right? So you make design or technology choices today, so you look for for the latest and brightest out there, and obviously you don't want to lock yourself in a given technology or a given vendor today, and you want to still retain the freedom to benefit from the whatever enhancement that can come later on, whether they are hardware related or ASIC related or NOS related or even protocol related, right? On the other side, if you are an operator, you care more about, or you're most likely up against things like dealing with resource planning and resource constraint, and the need to have knowledge retention in your teams and deal with those challenges. You also have to deal with the typical processes related to infrastructure changes and going from tech reviews to approvals and so on, which typically can be more or less time consuming and can in a way slow down the agility, which is one of the objective of the typical architect teams. You also have this major concern, which is the reliability. It's probably one of the number one challenge that the operators are facing. So the ability or the need to deal with changes in a reliable manner, because this is also part of your daily jobs, right? So you do have different automation solutions out there in the DC space, and of course some of them are addressing the architects more than the operators and so on. We strive to come up with a technical solution for both, and hopefully we're going to explain that or elaborate on that in this session. So Apstra, if you look at the claim or the technical claim that we have, we are in the business of intent-based networking. So what this means, right? So from a high-level perspective, this starts with the idea that we want to focus on the what and let the systems derive the how from that. So we want to raise the level of the declarative nature of the user input at a higher level than before, and this matters because the more you have your user input, which is declarative, the more you get closer to this abstraction, which gives you really agility and going into this cloudy operations, right? So abstracting stuff away and raising the level of the user input to a minimum required is an absolute requirement to have to meet the agility requirement from the architects teams. So the starting point for us is to really recognize the system or the networks as a distributed system, right? So we don't want to manage boxes individually, we manage systems, right? So for us, the goal is to have the operator express what the outcome of the system should be, and let AOS or let Apstra derived from that the necessary steps to get there. So really raising the level of abstraction to something highly declarative and letting the system derive from that or generate artifacts to generate all the configurations required as well as all the expected validations is the way to go. And what's important as well is that this user specification, this user input, this what is actually modeled in the backend of iOS in a logical model, meaning it's completely decoupled from any vendor or any model. So we store it in a completely logical way, and that is also a major enabler in the agility. So from there, not only we can, of course, select any given model here and there, but having a logical definition of the user intent, not hard-coded to any specific device, is also what enables us to have this closed-loop automation assurance that we have in the middle. So what this means is that the product will go beyond configuration. It will also generate a set of expectations that the system has to meet, and those expectations are derived from the logical intent, because we know the high-level intent from the beginning. So we are then able to derive very detailed expectation to then automate the data collection of those telemetry, as well as the analysis of the telemetry and compare it to the expectations to dictate whether the overall architecture is behaving as expected or not. So it's really going beyond this configuration and having some form of monitoring, but a monitoring which is contextual to your intent. So it's having like a tool that automates this monitoring activity, but with the context in mind. So obviously the advantage for you is, from a day two perspective, is the ability to deal with changes reliably, because you have in a combined solution both your day zero, day one, as well as your day two solution, which is aware of your intent from the beginning and able to validate it in real time and on a continuous basis. So to recap that, IBN, right, if you want to come up with some form of definition, even though there is no real formal definition of IBN, I mean, we have people within the company who are contributing to some IETF draft to come up with some normalization there. But from our perspective, it's basically those three pillars. The first one is having a unified tooling around a single source of truth. And it's actually, this is going to be the major focus of the rest of my presentation, is explaining how Apstra acts as a single source of truth and what implementation backend we have selected there to create a single source of truth that is able to cope with the DC challenges. The second aspect is the idea that you want to automate the entire life cycle, right? You want to have a single tool that is being used by architects to design in a logical fashion, using logical building blocks that they can assemble to create predictable designs and scalable designs, and having also a design disciplines where the systems prevents you from designing something that is not a by the book regular leaps on architecture and so on. So we inserted a lot of expertise even at design level to prevent the architects from shooting himself in the feet and eventually creating something that is not going to scale from a DC perspective. And then going from the design to the build process, where you will instantiate whatever in logical templates we have created at design time, and let the system as well apply this pets versus cattle mantra, where we will basically automate the distribution of variables at scale in a very automated way. A typical leaf-spine fabric consumes a ton of variables. You don't want to basically be prescriptive in assigning every ASN or IP loopback in a big 5-stage network. So you want to have an automated systems to manage those infrastructure variables at scale. And then moving, of course, to the operator phase, where you want to have the ability to define services in minutes and have them deployed in minutes, as well as operated right after the configuration push. So automating the entire life cycle is important, and for that you need to have a single source of truth that is able to feed all those steps. And then the last pillar is, of course, being multi-vendor. As I said, we completely decoupled the user intent from whatever is being selected underneath. So for us, the hardware selection is something that arrives quite late in the process. You do it almost at the end of your build, right before you hit the commit button. So what's the one of the major challenge when you build a network automation solution is to have a reliable source of truth. The source of truth is really the way you express your desired outcome, and you need to have something that is really adapted to the network domain that you are tackling, in our case, data center fabrics, and you need to have something really extensible enough, as well as programmable enough, as well as something that you can query in a very efficient way, because the source of truth is something that you query all the time, so you ask questions to that source of truth. So there's a lot of requirements with regards to the implementation that you have there. So the choice that we made in Apstra is that for this product is that we selected the graph database, right? So graph databases are a type of database that is out there. They have been around for quite some time, and it's one of the really powerful and mature technology out there when it comes to databases. For the history, I mean, it has been used initially for with social networks and so on. So it's something that really comes from the Twitters and Facebooks of this world, and it's used in a variety of domains for a modeling practice, right? So we in Apstra have been strong believers that to model an intent, graph databases are very suited. So for example, when we talk about Yang data modeling and so on, these are very well suited to have device level modeling, so it's quite lower in the stacks. But when it comes to having a system modeling or an architecture modeling, graph databases are very well suited. So, and I'm going to elaborate on some of the reasons there. So, the first one is that graph DBs are very efficient to model highly connected data domains, right? You, instead of storing the data in tables, in tabular formats, you're storing them in nodes. And in graph DBs, nodes are interconnected with relationships, and relationships are as important as the data in the nodes itself. So the way data is interconnected is as important as the data itself. And data center leaf-spine network is a highly connected domains, right? It's densely meshed network between leaves and spines, or spines and super spines. It's also quite complex from a services running on top, especially if we talk about EVPNs, the various layers you have there, from underlay to overlay, are quite complex. So you need to have a way to capture this highly connected domain, and graph DBs are super well suited for that. The other reason is that it's highly extensible, right? It's kind of schema-less. I mean, it has a schema per se, but that schema is super extensible. As the requirements evolve, you can add new node types and new node relationships and extend in any direction you want. So it's extensible or even scalable from that perspective to cope with new network requirements. And the last one, which is very important, is that it exposes very sophisticated query languages, right? So it's something that allows you to ask very complex, multidimensional questions in a very efficient way, much more than any SQL, query language if you are running a traditional RDBMS database, right? And those three elements are pillars that we rely on. And I'm gonna elaborate on why. So anytime you will use Apstra, whether via the UI or API or anything you express an intent, you design a template, you design or express any policy from an EVPN perspective or routing policy, that user intent is stored in the graph DBs. And you see here, nodes in the relationship and so on. And this graph DB will serve as the source of truth. Anything will come out of that being configuration rendering or expectation rendering, as well as cabling map. Anything is an artifact of this graph DB. If you look at the typical UI in the product, you will design a very, very small leaves by network. You have 2 spines, 4 leaves here, a couple of servers in every rack. iOS will basically see your intent in this form, right, with a couple of nodes and relationship and so on. So you still interact with your traditional UI to basically express your intent, but under the hood, we capture that by adding nodes in the relationship and so on to understand your intent and overlaying physical as well as logical aspect to that. Now, if you scale that to, we have major telcos that are using the product with, few hundreds or many hundreds of devices per DCs, and with data center interconnect and so on. So we're looking at potentially hundreds of thousands of nodes from a physical standpoint, and thousands of VXLAN services and so on. So this translates into something that will basically be represented on the right. Our largest customers basically have something between 20 and 30 million relationships in the database, and modeling, more than 1 million EVPN routes and so on. And that is how iOS sees the network. So from there, we can then do a number of things. So we don't need to, like traditional automation solutions, store things that are basically a result of the intent. So we don't store device configurations. We don't store cabling maps. We don't store typical artifacts like this. All of those are result of computing the graph. And we leverage lightweight processes that can be parallelized to run those tasks and run their configurations, as well as run their telemetry expectation, as well as collect telemetry, as well as compare those telemetry in real time. So we model really the bare minimum in a graph database, and we let the system derive from that everything that is required. And why this is important is because then the tool itself will have a complete understanding of the network. So if I take the small leaf by network we have seen before, the graph representation of it will more or less look like this. I will have like 2 spines and a couple of leaves. So you see the physical representations, and you see all the logical representations, typically EVP and VXLAN services here. So you see nodes modeling virtual networks, and then instances of those virtual networks connected to specific leaves, and then eventually SVIs if you're enabling VXLAN routing, and so on and so forth. So typically, this is how iOS will capture the user intent, and from here we will have a number of steps that will happen. The first one is what we call preconditions check, meaning the system will check the user input for any new service that is expressed. And then once you pass those validation, we will basically enable post-conditions check, which is deriving the expectations and making sure that whatever configuration or state we have enforced on the switches is actually being met. So I'm going to take examples of the preconditions check, which is an important part of the automation as well, and then the post-conditions check, which falls into the validation category. So the preconditions check is anytime you are in a run phase, so you have a running infrastructure and you are requesting new services, right? You are requesting new, a new routing policy, a new ACL policy, anything that you express in the system. So this is a screen capture that shows that you are staging a new intent, and iOS will perform a number of semantic validation, meaning it will look at the user input and make sure that it is complete and exhaustive in terms of user data, as well as the fact that it's not conflicting with any existing data or policy or whatever. So the idea here is that because you have a system modeling of the user intent, the tool is able to make sure that at no point in time the operator is triggering an automation workflow with data that will break at the end, right? So what happens here is that if there is any data that is missing, or data that's provided but in the wrong format, or provided with the right format but conflicting with the previous policy, or anything that is deemed to be incorrect, you would have what's called build errors. So these are preconditions check. A typical example is duplicate IPs. So as a human, even if you use an automation tool, you can create two services in the same tenant and have the same. So the two services have the same IPs by mistake, and the tool is here to prevent you from doing that. Prevent you from doing that is stopping any commit possibility. So you do not see any configuration being sent to the switches. If there is any build error, we just grade the commit button and stop the API equivalent endpoint, right? So, and that's important for us, right? To basically make sure that there is an in-depth verification of the user input, and this is leveraging all the system validation. So this was precondition check when you typically stage a new service or create or basically do any add moves and changes to your intent. So making sure you are not basically going to make a change that will break the network. Again, it's really de-risking those changes. And then let's say you have passed this user input validation, and whatever user request you have put into the system is deemed to be feasible. So the system lets you commit it at any point in time when you're ready to commit. So the configuration rendering will be generated and pushed to the new devices. Incremental configuration will be handled, and so on. And then you will have also the expectation rendering in the tool that will generate expectations and compare those expectations to the actual data in the infrastructure. So I'm taking here a typical example of something that is quite symptomatic from today's challenges, which is EVPN, right? So when you configure EVPN, which is one of the complex protocols today, you have a lot of states, a lot of routes, and for the first time you have more service routes than actual customer routes, right? So, EVPN route types 3 and 5, for example, which is in this example dashboard here. These are infrastructure routes, and you need them to be present on the switches right after you configured any layer 2, layer 3 VXLAN, irrespective of any user traffic or any customer basically consuming those EVPN services. The consumption of those EVPN services will trigger additional routes, but these are really infrastructure routes. And here you have something that, in a contextual manner, anytime you request, 50 new VXLAN or 2,000 new VXLAN services, it will automatically derive the expected routes it is supposed to see in every switch in a very detailed way. So, 15 here and 9 here is, those are counters that are related to a very small infrastructure, and showing in this case a deviation, the fact that 3 of the expected routes are missing, and 3 here of the expected route as well in the EVPN type 5 are missing on the switches, right? So if you want to do this manually, you will typically type show commands. So these are show commands from Junos to look at the BGP VPN routing table and requesting show me the type 3 routes and show me the type 5 routes, right? What we see here is that, first of all, the user input is not obvious. The data output is not obvious, right? Because this is NP-BGP. We have to deal with route distinguishers, with route targets. The interpretation of the data is not obvious, and moreover, if something is missing, it's quite hard, or sometimes almost impossible, for a human to cope with. So you are typically looking to use show commands to troubleshoot something that, at scale is very often almost impossible to do from your perspective. And scale here, the moment you exceed 10 racks with few hundreds of VLANs stretch, you reach that scale. So you're typically like, okay, I'm typing show commands and it looks good to me, but if something is missing, you rarely are able to see it. And what we do here is we have something that automates those expectations and those checks, and the level of checks we do on day one, like when you stand up the fabric and deploy your first services, is exactly the same as the number of checks that we do, let's say, in 6 months down the road after having added 50 racks or 100 racks and I don't know how many virtual services. The objective here is to have something that makes the same checks consistently in a continuous manner, with the purpose of having no technical debt whatsoever, right? You don't have any configuration drift because there is no incremental configuration that is pushed to the switches if there is no automated expectation that is generated and automatic data collection from the switches to compare and to automate the comparison of that data to the expectations. So that's for us, an important, aspect of how we want to de-risk day two changes and make change management in today's operations being something that is not scaring every teams or every operations teams. So typically here the typical user will look at the output and try to see what do I have here? Am I having the right VTEPs for the right VNI? Am I missing something? What entry I'm expecting to see for a specific VTEP? And do I have the right product distinguishers-driven approach? It's kind of impossible to derive this expectation in real time. You cannot use the configurations to derive these expectations. It's a very hard problem to solve in software. Configurations have to be a result the same way as validation has to be a result of a more logical definition of your intent. So moving on and to illustrate what this will look like after having looking at the backend implementation. So you will see things like this. So this is an example of the BGP peerings. You see on a typical switch a number of expectations, and you see an expected versus an actual column, and of course any deviation here is marked in red, and this is updated in real time as you add racks or services, and you see this contextual monitoring and continuous validation. You don't have to worry about which IP address is used for which spine and so on. We leverage all the data modeling and the rich model to present you with any information to pinpoint and understand what's being wrong in which part of the infrastructure. So this is an example on the BGP routing. On the routing tables, you have other examples like this. I have shown before the VPN or the overlay routes. This is looking for the underlay routing. Do I have the right entries in my routing tables on every switch? Yes or no. I have an expected versus an actual comparison, and at no point in time I am bothered with meaningful or meaningless alarms. I have only contextual alarms. Anything that is red is contextual to an expectation, right? And then you have other type of validation or telemetry that is not necessarily deterministic. It's more like traffic oriented. So show me the path between any two endpoints in the fabric. I pick one server in one rack and another server in another rack, potentially in different pods, and I want to see how the traffic is flowing or how the fabric is behaving between those two endpoints. So I have here examples of a three-stage topology and showing the path between two specific endpoints. So again, this is really traffic oriented. Let's say I have also the right routing entries and the right configurations. I can query the system to check for any imbalance situation. And there again, this is irrespective of the right or wrong configuration. You may have the correct configuration of on the switches, but still have an unbalanced situation, which is symptomatic from any elephant flows that can arise in your network. So you also have dashboards that look for ECMP imbalance, both layer 3 CMP inside the fabric or layer 2 CMP, which is between your servers and your leaves. This is more. It's a bit more difficult to generate alarms here. Or to create an unbalanced situations, but you get the idea of how the gauges will evolve should there is any imbalanced situations. And the important here is that you can define your own, provide your own definition of what an unbalance is. This analytics pipeline that is behind this dashboard here has the ability to gives you the ability to customize the definition of an imbalance by saying the amount of standard deviation that you tolerate between links, as well as the observation intervals, so that based on the traffic pattern, you want to be alerted if an imbalance is matching a given condition, which is probably different from one customer to another. So all of this is highly customizable. And then other views of the leveraging the data model is that, again, you can interrogate the source of truth very easily, and you can create dashboards like this to say, I want to see the north-south versus east-west traffic distribution, right? And from design time, we have modeled what an external link is, and what the fabric link is, and what the server-facing link is, and so on. So querying the source of truth and creating a dashboard out of this is extremely easy. And more importantly is that when you create a dashboard like that, it's in sync with your intent. Meaning the moment I add external links for whatever reasons, because I need more traffic towards my MPLS-PEs or my WAN or whatever, this dashboard is automatically aware of any modification. So it automatically collects data related to new interfaces because it's aware of a change that will impact the data collection here. So there is no more disconnect between someone managing the configuration and someone managing a monitoring stack, and the need to update the two. There is one and only one single source of truth serving any single feature in this product, being configuration or validation, right? So the data modeling leverages this in real time. And then carrying on, like what else can I do with the graph modeling of my source of truth? Well, what I can do is that I can do diffs between different versions of the graphs. And diffs here is meant, the same way as a git diff. If you look at an analogy in version control, right? So the system can very easily compute diffs between an existing version of the graph and the previous one, right? And what this allows me to do is to really version control my network. And so Junos have had this amazing rollback feature years ago, which is certainly, I mean, something that every network operator has been amazed with, and we just use the same concept but make it system-wide. Meaning, I can at any point in time roll back an entire fabric with 2-3 clicks away. I can come back to a previous revision, and that can change configuration on one switch, 10 switches, or 100 switches at a time. So we store the latest revisions, like the 5 latest revisions, and we allow you to store 25 other ones for life if you want to store them forever and roll back to them. So imagine the power of the rollback on a specific device and making it system-wide, knowing that we manage very large data center leaf-spine architecture for customers. And yeah, this feature is called Intent Time Voyager, so which is basically what we just mentioned. And the bottom line is that, again, we want to manage the infrastructure as a system and not as individual boxes, which is in our view the only way to reach this agility. Even though under the hood you get access to configuration rendering of every switch, but you manage it as a system. And then moving on, this graph database that we mentioned is also something that we can use to ingest as well data from external systems. So we have third-party integrations, and one example of that is third-party integrations with VMware tools, so vSphere and NSX and so on. We can then create additional nodes in the relationships in the source of truth to model data coming from another source of truth, but for which we want to be aware of to validate our domain. So I'm going to explain this through an example. We have this integration with NSX, and what it allows us to do is that we will obtain through a read-only API through NSXT Manager, we will get the identity of all the VMs, all the transport nodes, all the as well as the uplink profiles of every VM, and the microsegmentation policies, and you name it. So a number of information that are outside of our domain, but for which we want to be aware of, because it allows us to then correlate that with the underlay, right? So we then have the ability to know what VMs we have running in the fabric, where they are located, like what ESXi is hosting them, and which type of rack is connected to that ESXi, and what are the user intent from the VMware administrator, and do I have the right configuration in the fabric, or the right user intent in the fabric to satisfy that, right? So that we can bridge the gap between the two domains. And once we enhance the graph database with this information, we have automatic validation pipelines that pops up and lets you know whether there is a discrepancy between one domain and another. And typical examples is I do have like a requirement for a VLAN back interface from VMware, and this one is missing from the user intent. So the network admin has just not been aware or been notified that he has to create a new service in iOS. But with that, he'll be aware that he'll soon get probably a phone call or whatever from the VMware guys to say, hey, I need this VLAN here, or I need you to change the MTU or whatever. So we empower the network administrators with knowledge outside of the network domain, and in some cases, exposing auto remediation workflows, right, which is a way that Apstra has to let the user know that, hey, you have like, I don't know, 39 anomalies here. Click this button, and I'm going to do the add moves and changes to your intent automatically for you to change the underlay to make it in sync with the overlay, right? We do not make any modification on VMware part. There is a management tool for that, but we can take the requirement from there and automatically make the underlay fabric part being in sync with those requirements. And the goal is to really speed up the deployments and avoid being a bottleneck when it comes to underlay overlay validation. And all those examples, any dashboards you have seen, any dashboard is under the hood highly customizable. So this is the anatomy of an analytics pipeline in iOS, which is behind any user dashboard, irrespective of how this looks, whether it's a Gauge or whether it's tabular or histograms or whatever. So an analytics pipeline is composed of those three components. Each one of them is customizable. So you have the telemetry collectors, which is an SDK. We give customers to enrich the data set, or the data that is collected from the switches, go beyond the built-in telemetry collectors that we have. So this is really the ability for you to extend what's called the raw data collection, like anything that comes out of the switch. You find a data structure and how you want to stream this data into the telemetry framework. So this part is, as I said, customizable. And then once data comes to the iOS server, you can then create a user-defined, highly customizable pipeline in blue, where you can select various processors. So processor makes a specific, manipulation or correlation or reduction or processing of this data. So the selection of those processors and the way you chain them together defines an operational workflow. And there is like a list of different processors, and the use cases are really wide, because you can really combine them in very different ways to basically, compare the data, time series it, do periodic average, and even more complex calculations, right? And then you see the red part in the top. So all of this pipeline is always in sync with your source of truth. So you define a query to the source of truth, which defines the scope of application of this pipeline. And then it's a zero maintenance feature. Like anytime you add, move, and change anything from a physical logical standpoint in the fabric, you don't have to notify or change or maintain this analytics pipeline. You have automatic notification and increasing or reducing the data set to collect new data, because it's subject to analysis here. Again, single source of truth for configuration and rendering and validation. Sorry. And then last point, and then I think I will probably be almost on time. Last point is that we create automatically APIs for any pipeline that you create, right? Of course, we have APIs for all the configuration part, right? That's certainly mandatory. But any user pipeline, any analytics pipeline that you create for any use case, you have API endpoint that allows you to get to any stage, meaning to any processor, which is available for you to have third-party systems query the data being raw, which is at the far left, or being processed in the middle, or being totally analyzed, which is closer to the far right, where you can extract more insight out of it. So that's one method to obtain the data, and we also have the ability to stream this data to external data lakes with Google protocol buffers. So all data being collected at the Apstra server is aggregated, normalized, and so on, and enriched with metadata as well, so that you have consistent experience. And then we stream out the data from the Apstra server to a Google protocol buffer telemetry collector. So, we typically have plugins for Telegraph because we like this modular tool, and customers, can then, select any time series database to write data back. So you can basically have practice to use APIs to program the Apstra server to collect or parse new data in specific formats you're interested with, and you have then this Apstra server that can stream the data to this data lake external stack that you have out there. These are just examples of very common TIG stack or ELK stack that we interface with. To recap, we have a solution that allows to configure and operate with very powerful but powerful and customizable analytics engines. So powerful in terms as it's automatically available for you, and it's of course highly extensible to fit any customization. So which allows us to address day 0, day 1, but day 2, which is the major challenge in network operations. It's a more difficult problem to solve. And of course, allowing you, of course, to enforce any compliance policy that you want on top of the built-in validations that we have. If you are interested, we have different resources. So there's a YouTube channel where we explain in 5 to 10 minutes different parts of the product, from the design to the validations and so on. So I encourage you to have a look if you want to get a glimpse of how the product is operating. If you want to spend more time, we have Apstra Academy, which is a self-service training tool. So it's something that is a full day training, but you can basically do it at your own pace. But it's 3 days worth of instructor-led training with various modules broken down with some form of deep dive explanation there, and you have the virtual labs that you can use to stand up virtual environment. We will basically create small topologies, generally 2x4 or something, but really enough for you to at least appreciate the major part of the major features. We generally stand up this with virtual switches like virtual QFXs or virtual other NOSes, but the user experience from the Apstra perspective is exactly the same, whether it's a physical switch or a virtual form factor.